Okay, so I got the recorder up and running, and let's go ahead and go over the questions. Alrighty. Okay, first question. The first question wants you to replace a single JA, which is jump if and only if above instruction, with any number of the other instructions and labels. So you can have JC, which is jump if carry, JZ, jump if 0, and a conditional branch. And you can also define as many labels as you feel is necessary. In other words, it's about the same kind as the practice test, and I think in some ways this one is easier. Okay.
It's like that.
Well, I mean, jump if above. Okay. So the first thing we want to know is what does it mean when something is above? Okay. So above means what? Yeah, it means which conditions have to be met. If a number is above another number, can it be the same? Cannot be the same. So that means the 0 flag has to be cleared. Okay. If a number is above the other number, do you think the borrow flag or the carry flag should be set?
Carry flag should be 0.
Should be cleared as well. So the C should be 0, and all other flags do not matter. Okay, just these two flags are important, and both of them should be cleared. So now that we know jump if above requires the 0 flag and the carry flag both to be cleared, but you're only allowed to use the positive version of carry and 0 conditional branches. So what we need to do is to think about, okay, so how do we do this? All right, first thing is, it doesn't matter which one you pick, just pick one to go first, okay? So you say JC, okay, jump if carry. Now if carry is already set, it means, should we go to label L1? No. So we just go to a continuation point. How you name your continuation point does not matter, okay? You can say cont, L2, whatever, okay? So if we don't go to the continuation point, it means the carry flag is cleared, okay? So the only other instruction you can do at this point would be the JZ instruction, which is saying, okay, I know the carry flag is clear at this point. What about the 0 flag? If the 0 flag is also set, we also want to go to the continuation point. So at this point, we did not branch because the carry flag is set. We did not branch because the 0 flag is set. That means both of those flags must be cleared. And as a result, this is the condition to jump unconditionally to label L1.
Yep.
Because by that time, we have confirmation that both of the flags that we need to deal with are both cleared. Okay? All right? Yep.
Is it okay to have different labels for JC and JZ?
Yeah, you can have different labels. You can reverse the order. The order does not really matter.
Happens in the labels, right?
Yeah, this label just has to be consistent with your actual continuation point. Yep.
Is it okay to make a label L1 just to show place to jump?
There's no need to define L1, but what I'll be looking for would be these 3 instructions and this particular label here.
No, well, I think what he's getting at is kind of what I did, in that I put a little bracket underneath where you have JZ count, and then I just said, okay, here's where your code would be to execute if this was true, and then underneath that, you have a jump. Then it'll. Don't worry, I've lost my train of thought.
That's okay. When I see your answer, I will take a look at it and see whether it reflects that you know how to solve this.
As I recall, the jump command was pushed lower, so they automatically fell through that code.
Okay.
But then once you did that, you made sure to jump over L1 because you don't want to execute L1.
Okay. As long as it works. I mean, there are different ways to do it. This is just how I would do it. I mean, there are other ways to do it too. Okay, question number 2 is new because this is replacing the oops, I should have done that. It's replacing the other question on floating point numbers. Okay, so this one is not asking about floating point numbers, but it's asking you about 64-bit numbers. We did not talk about the add with carry instruction, which would be very handy for this type of thing. So the key is this part here. The key is when you add these two numbers, okay, because EBX is all F's already, which means there are 32 ones in this particular 32-bit number. When you add a 1 to it, it will generate a carry, okay? Now the carry is not a problem for the least significant 32-bit, but the question is how do you get a carry to the most significant 32 bits? That is the question, right? Is that okay? All right. So that means, basically, when you're done with the least significant 32-bit add, how do you add that 1 to the most significant 32-bit of the 64-bit numbers? So the way to do this in assembly code is to use your regular add long instruction, add the least significant byte, and in the class, because of the correction, the example is correct. Okay, EAX is the most significant, EBX is the least significant. So what we do is we add EBX to EDX because these two are the least significant 32 bits of the 64-bit numbers. Did you flip it?
Yeah, I even glanced up at what you had on the board, and what I read on the board was the same as it was.
If you flip it consistently, it will still be okay.
Okay.
I can grade it, assuming that if you flip it consistently and your answer is correct.
I drew on the side which ones were
okay.
were which. So.
Yeah, that's okay as long as it's consistent, because it's my fault not being consistent to begin with. Okay, so the next instruction is the important part, because we cannot do another add L just yet, because we have to remember, is there a carry from this addition? Okay, so now you have to separate it into two different cases. And the way I do this is I would use a JNC, which means if there's no carry generated because of the least significant 32-bit add, I would just go to label L1, and I'll define label L1 here. Now, the question is, what if there is a carry? We just need to add 1. Okay, so we need to add 1 to the destination, because the destination is supposed to store the sum, and the other number is not. So at this point, we have to add a 1, okay, it has to be $1 because it has to be immediate, to not the least significant 32-bit, but the most significant 32-bit of the destination, and that turns out to be ECX, okay? So we have to add it first, and then it can fall through to label L1. Then we actually add the actual registers, EAX to ECX. Yep.
So if I use the sign flag instead, is it okay?
The sign flag?
Yeah.
No, the sign flag is not going to work. It has to be the carry flag. Because the sign flag does not indicate whether it has a carry from bit 31 to bit 32. That carry is what we need to pay attention to, not the carry from bit 30 to bit 31. That one is not important. You can implement your instruction, okay? Just do your own code with the sign flag and see if it works, because it's not going to work. The sign flag approach is not going to work.
Yeah, because I thought I had to look at the sign flag of the result of the add.
You can still get partial credit if you get the overall structure right, to basically know that you have to add up 1 to the destination in case there is a carry, okay? But missing this carry here will definitely cost you, some important points, because that part is important.
So is it okay for me to add 1 to EAX instead of ECX?
Say that again?
Is it okay for me to add 1 to EAX instead of ECX?
No, because EAX is not the destination.
No, I mean add 1 so increase.
It's not really as good as this, because if I did not designate something as destination, you really should not be changing it. It didn't say that in the question, so I cannot really ding you for that for points. But in general, if there is a way not to change a register that is not supposed to be changed, you really should not change it. So that's question number 2. Moving on to question number 3. Question number 3, I think, is actually easier than your practice question. So in this case, I'm just going to use 50 as my example, and you guys have your student ID to use. Okay. I hope no one has 00 as the least significant two digits, because that can be a problem. Compared to 0, there's no way you can actually end up with the carry flag being set. But nobody complained and say, oh, this is not going to work out for me, so I'm assuming nobody had 00 as the least significant two digits. All right, so whoops, I'm just going to use 50 as the example, okay? All right, so the question is really asking, okay, this is what the question is asking. It's asking, question mark minus 50 is going to generate a borrow, okay? So what do you think is going to generate a borrow? What do you think the question mark has to be? Remember, the borrow flag is effective when we look at things from the unsigned perspective. Okay, so basically we are saying if the question mark is less than 50, interpreted unsigned, then we will end up with a borrow. Is that okay? And what do you think is the first number that is less than 50?
49.
49, yep. So 49 is 1. It doesn't matter the ordering here. What about the other one?
0.
Yep. So you can say 0 to 49, you can say 49 to 0. It doesn't have to be, from low number to high number, okay? Or any other way you can specify the bit pattern. So 49 in this case is, you can also specify this as 0x31, which is in hexadecimal. You can specify this in binary, which is 0t, because t is for binary. 00110001. So any alternative to specify the same bit pattern is okay. Are there any questions?
I had kind of a brain fart when I did. Now, in this case, I would have put 49 and not to 0. I put a negative number that with my number would have brought us to. It's wrong.
Okay.
So like I have one and then the other one, but it's still below. Like how is that 2 points? Is that 1 point?
This is a 4-point question.
Okay,
So
what's
if
the
you,
loss?
so it's a split.
Okay.
Yeah, you can get one half right and the other half wrong. And I will take also minor points off, for people who indicate like, off by 1 kind of thing. Instead of having a 49, you have a 50. That would be like a minor ding, but it's still wrong if it is 50, because 50 minus 50 does not generate a borrow. Okay, question number 4. The following code is supposed to find the maximum of EAX and EBX interpreted unsigned with the UN in boldface, because in the original question it is signed, and I want to make sure that you guys understand this one is different. It is unsigned. Then update ECX with the maximum. It does not quite work the way it's supposed to. This is the code. And you can probably find out, the problem is it is using JL instead of JB, right? Because if EAX is below EBX, then we should use EBX as the maximum. Okay, so if this is JB, it would have worked 100%. But because we use JL, it works sometimes, it doesn't work other times. Find the test case that this program will fail, so it does not end up storing the maximum of the values of EAX and EBX in ECX. Okay, so this is also reversed, because in the original question, I'm asking you for a case where it will work. Okay, the code is wrong, but the test case will still work, convincing the programmer that the code is actually working. This one is asking you for a case where it will not work. Okay, all right, so what is the main difference between JL and JB? Not even looking at things from the flag perspective, what is the main difference between JB and JL? One is signed and one is unsigned. Okay, very good. So that means what you need to do is to think of cases where this would have worked if it is signed, but would not have worked if it is unsigned. Now, if you look at the number wheel, half of the number wheel have exactly the same value regardless of whether they are signed or unsigned. All the non-negative numbers for A bits from 0 to 127 would have done the same thing, right? But the other half would be completely different, because -1 is actually 255. So the values are very different in that case. So in this case, I'm looking for long, and you can certainly use decimal numbers if you want to, which makes it a lot easier to deal with. So what you want to do is to compare basically signed numbers. Okay, one would be a -1, and the other one is a 1, and that will automatically fail. Okay, so let's just look at this as an example here. So I'm going to use 1 as a -1, and the other one can be just a 1. Okay. So let's see how this one is going to fail. Now, -1, by the way, is also 0x FFFF, or a little bit more than 4 billion when it is interpreted unsigned. Okay. All right. So if this is the case, okay, EAX is -1, EBX is a 1. If you subtract 1 from -1. The less, okay, let's see. The less than flag is saying EAX is less than EBX, which in this case is true because -1 as a signed number is less than EBX, which is 1. So that will bring you to L1. L1 is going to move EBX into ECX, and it will say ECX is now the maximum. Okay, when you look at the signed values, 1 is the maximum of 1 and -1. But the question is quite clear to say that find the maximum of EAX and EBX, and they have to be interpreted unsigned. But when it is interpreted unsigned, -1, or the bit pattern to represent -1, is actually representing a value that is more than 4 billion. Should have chosen the other way. So anytime you have one as a negative number, the other one as a non-negative number, it would have worked. If you have two negative numbers, it's not going to work either. Because -1 is FFFF, FFFF, but -2 is FFFF, FFFE, so it would still have found the correct number in that case. So it has to be like one is negative when interpreted signed, one is non-negative when interpreted signed, then it will work. It doesn't matter which one is which one. Is that okay?
Yeah. Like the interpreted unsigned, I got focused on, and then when I looked at jump it flower, I was thinking that we're not to look, because this to me, right, exactly, like you said, it's the going around the circle, and then you're actually looking at bigger numbers instead. But because I saw unsigned and then jumped down, it's like that one little nugget of information I lost kept me from doing the entire program. Was because I didn't realize, or at least I didn't remember that jump if less than and jump in below the two difference. I just thought there was jump in less than.
Oh, one is for sign and one is for
yeah. I know now.
Yep. Because JB is the same thing as JC, but L is the exclusive OR of sign and overflow. Then suggest a fix so that by changing one single instruction, this code works for all unsigned numbers in EAX and EBX. So the change is from JL to JB. So JL should be JB. That would fix it. Yep.
What if I said L should be JNA?
Yeah, me too. I use that one. Does that work?
JNA would work too, because when they're equal, it would still be the same, and it doesn't matter which way you flow. So JL should be JB, JNA, JC. Is that I think that's it. Okay, or JC. So those three are possible alternatives. Because when two numbers are equal, it doesn't matter which one you copy; it will still be the same result. Okay, question number 5. I think this one is the favorite of a lot of people. So let's work this one out, step by step. It's just like with the practice question. You have to kind of show me the steps along the way. The first one is easy. EAX is really just getting the value L1. Okay, whatever the definition of label L1 is, EAX ends up with that value. Is that okay? Because it's just treated as a constant in this case. Well, the second instruction should be pretty easy too. You're just adding 4, whatever to whatever EAX has. So EAX is just increased by 4, so now it has the value of L1 plus 4. Yep.
For the first move L instruction, if L1 was a direct movement instead of the immediate, and the second one add L4, it would end up the same way.
Okay, you're saying if this
If that
dollar
one
sign
was-
is missing?
yeah. If that one
Well,
was
if the
direct-
dollar sign is missing, it's going to be PQRS.
Okay.
So the second line would be PQRS plus 4.
Okay.
Yep.
All right.
All right, the third instruction is a move indirect, which means EAX would end up being the indirection of L1 plus 4, okay? But since this is using a move long instruction, it's going to move like 32 bits at a time. So what is at the location L1 plus 4? L1 plus 10, very good. Okay, so we have L1 plus 10 as the final answer in EAX after the third instruction. The fourth instruction is kind of the same thing, but this time I'm putting whatever EAX points to into EBX. So L1 plus 10 is tricky because the first byte, which is RS here, this is at label L1. The least significant byte of this guy is at L1 plus 4 because a dot int is 4 bytes long, which makes this one L1 plus 8, right? Plus 0, plus 4, plus 8, okay? This is going to be plus 10. So MN is the byte that is at plus 10. And where's plus 11? It's the most significant byte of this particular dot word, which is going to be 0. Exactly. So in this case, EBX is going to be, what about the other the other 2 bytes? So it's going to be MN00, and then the other 2 bytes will be these 2 bytes, QR, and then we have OP. Which one is the most significant byte? OP, yep. So this is going to be 0x OP QR 00 MN. Is that okay?
Are you writing that in Little Indian? Are you writing that in Little Indian form?
No, when I write a number, it's always the same as when we write any number, which means the left-hand side is the most significant and the right-hand side is the least significant. Because when you spell out the content of EBX, endianness does not apply. Is that making any sense? No? Okay, the MN here is at L1 plus 10, right? Well, maybe not. Okay, hold on a second. Let me just double check. This is plus 0, plus 4. Oh, I got it wrong. The plus 10 is,
I think MN is first.
okay. The plus 10 is here. Nope. Okay, this is plus 0, plus 4. This is plus 8, plus 9. This is plus 10. So plus 10, plus 11, plus 12, and then plus, this is plus 10. Okay, so, okay. Plus 10, plus 11, plus 12, and then plus 13. Okay, so it's, so it would be 00 MN and then MNOP. Nope? Okay. I'll spell out the actual bytes. This way it will be more visible.
Did you put the
Okay.
number in Excel?
So let's spell out the bytes. Okay, this time we'll spell the bytes. 0000, and then we have RS and then PQ, right? 00 being the least significant byte has the lowest address.
Why is that the least significant byte?
Huh?
Why is 00 the least significant byte? Isn't RS the least significant byte? Because when you
Right, you're right. Yep.
Yeah.
Yep. It's RS PQ 0000. Thank you. And then we have 4 bytes that are unknown because of the address. That's L1 plus 10. And then we have MNOP 0000, so we have 0000 as the least significant 2 bytes, OP and then MN. And then we have the dot word here, so MN itself is repeated here with the most significant byte being 00, and then we have QR and then OP. So these are the bytes that when we spell them out. The next line I will go ahead and show you which one is at L1. So L1 is here, which is L1 plus 0. So when we have L1 plus 10, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So L1 plus 10 starts here. So we're copying these 4 bytes into register EBX. But because of little endian, OP becomes the least significant byte, MN becomes the next 2 bytes, and then this 00 becomes the most significant byte. So this is correct. This part here is correct. The next instruction is a move W instruction. So we're only moving 2 bytes from L1 that will become these 2 bytes. So that means BX is going to become 0x PQRS, okay? But if you look at EBX as a whole, it's going to be 0x 00MN and then PQRS. Because BX is this part of EBX. And yes, go ahead.
Specify EBX there, or it's okay for me to just put BX?
Well, you can just go ahead and just write BX. But at the end, I want you to tell me what is in EBX. So you still have to figure out how the entire 32-bit register works out. Now the last one is BH, okay? So this one is fairly easy if you just look at BH itself, because it's at L1 plus 3. This is plus 0, plus 1, plus 2, plus 3. So BH becomes 0. But when you look at EBX as a whole, it becomes 0x00MN, and then the PQ is affected because that's basically where BH is, but RS is not affected. So the entire number becomes 00MN00RS. Is that okay? I made sure this program assembles and runs, so you can actually type it in and run it too.
No, for some reason my MN and this 00 were flipped.
Say again?
For some reason my 00 and MN were flipped.
Oh, these two?
Yeah.
Well, you will get some minor points deducted.
If we're off by 1 byte, is
What do you mean by
entire
off by
row
1
long?
byte?
If
But-
you have a question mark instead of 00, or I forgot what I did for the.
Okay.
exact
Well,
problem.
each particular instruction has its partial credit.
Okay.
Yep. Okay, question number 6. This is the last question. It's about coding. So this one is, I would say, about the same complexity, except this one uses pointers. And can anyone tell what this is really doing? What is it really doing?
Dereferencing a pointer to a front.
Well, yeah, but
Yeah.
overall speaking, what is it doing? It's trying to
Referencing
match.
EBX.
It's trying to match how many occurrences do we have of a particular character in a null terminated string. So give it a null terminated string, it will tell you. Give it a character to search for in AL, okay, and it will tell you how many times that character occurs in a null terminated string. Now, how do we know it's looking for the? How do we know we are dealing with a null terminated string?
This is a 0.
Because it's testing for 0, so we stay in the loop as long as the pointer is pointing at something that is not a null character. By the time it gets to a null character, it exits, it gets out. And then in the inside, this one is critical, because otherwise the string is not gonna, or the pointer does not move forward. And then inside here we are comparing basically what EBX points to the character AL. If it does match, then we increase EDX, which is a counter. If not, we don't do a single thing. We just do not increase the counter. But in either case, we will increment EBX because it is just moving on to the next byte. Okay? So the code to correspond to this is going to be, move L $0 to E dx because it's just a counter. And then we have a while loop. So with any while loop, you have to basically indicate the beginning of a loop, indicate the end of the loop, and right before the end of the loop, you have to have an unconditional branch back to the beginning of the loop. So this is basically just the structure of a loop itself. And then inside the loop, let me just scroll up here so that you guys can see it a little better. Okay, so inside here, we are basically comparing a 0 to where EBX points to. Okay, and this really should not look too foreign because we have that in the string reverse program as well. So in this case, we are comparing, let's not specify the width yet. So we're comparing 0, which has to be immediate because it's just a constant, with whatever EBX points to. And whatever EBX points to is EBX indirect, okay? But this is not okay. This instruction is not okay, as many of you have experienced this in your string reverse program. Why is it not okay? There's no width indication, right? There's no width indication in the mnemonic of the instruction itself because it's just CMP, and there's no implied width either from either operand. Because $0 can be byte, can be word, can be long, and whatever EBX points to can also be a byte, a word, or long. So if you leave it like this, the assembler will make the assumption and go, well, if you don't tell me anything and I cannot infer it's going to be long, which would not be correct in this case. So this one has to be a compare byte instruction. Okay, you have to spell out the byte in this case. Unless you move a 0 into, let's say, CH or CL, and then do the compare with CH and CL, in that case, the 8-bit register will imply the width of the operation. But if you're not doing that, you have to spell out this is a compare byte. Okay, so now we know that we have to branch to the end of the while loop in some cases. Okay, so when do we branch out? JZ or JNZ? JZ, that is correct because we have to invert the condition here. This is the condition to stay in the loop. We have to turn it around to specify the condition to get out of the loop. Very good. So by the time we get here, we have to handle the conditional statement. The conditional statement is comparing again CMP something, and this time we're comparing the register AL with whatever EBX points to. This time it is quote unquote okay to leave out the width specifier because the first operand is clearly spelling out we are comparing byte already. So in this case, if you leave out the byte here, the assembler already knows this is an 8-bit compare and not a 32-bit compare. But I would just specify the B anyway, okay? And in this case, we want to branch around the then case when it is not. So we say JNZ and if, okay? And if is going to be here, which means if we do not branch because of the JNZ, it must be Z, okay? Which means AL is exactly the same as what EBX points to. So in that case, we have to increment EDX, which is add long $1 to EDX. After the end if, we have to add 1 to the pointer itself, which is EBX, and then we have the unconditional branch back to the beginning of the while loop and do the whole thing again. So that's one way to implement this code using basically what we talked about in class. Are there any questions about number 6?
Could we have used JE or JNE instead of JZ?
Yes, JE and JZ are exactly the same. So E, which means equal,
Yeah.
is the same thing as Z, which means 0, because 0 flag is describing the flag itself. What it really means is just 0. But JE only makes sense after a compare. But they mean exactly the same thing, though. So you can use JE if you want to.
But you said only after compare for JNE?
No. Well, what I meant is, JE makes more sense right after a compare because it's saying equal. It's just like looking at JB as jump below, because it only makes sense after a compare because only then you can tell whether a number is below or equal to another number. But the actual description should be JC, which is the name of the flag itself, the carry flag or the borrow flag, and also the Z flag because it is basically saying after the subtraction you end up with a 0.
Okay.
So that's why Z is what it is, but E makes more sense after a compare. It just it just reads better after a compare.
Gotcha. Thanks.
Yeah. All right. Any questions? And remember, I will give you partial credit, because I'm looking for key points, like is the structure of the loop correct, okay? Not even counting the comparison, is the structure of the loop correct with the proper labels, the beginning, the end, and the unconditional branch, and whether you spell your labels exactly the same way that I do here. I'm just kidding. You guys can use any label as long as the positioning of the labels is correct, okay?
So how many points do you think you would take off for not putting parentheses EBX?
Well, that's a big one. That is a big one because if you don't put parentheses around EBX, you're comparing to the register itself, not what the register is pointing to. I have not worked out the rubrics yet, but that's one of the kind of important concepts. The polarity of the branch is kind of important too. So JZ versus JNZ here, those are also important because it determines whether your logic is working the same way as the C code or not.
You said as long as we have the structure of the labels right, we get credit for that.
You get
What
partial
about the
credit for that.
Naming of the labels. I use loop 1 and loop 2 instead of while beginner.
No, that's fine. That is okay as long as your loop 1 is what you use for your unconditional branch,
Placement is more
and then your loop 2 is what you use for the branching out.
Yeah.
Yeah. So those are the important parts. But how you want to name your labels can be L1, L2, L3, L4, which makes the program harder to read and understand. But I'm not going to grade on that.
A couple of
Yeah.
minutes left. It's okay.
Like I accidentally read you had the plus EDX, and then I read the second one as minus EDX. So everything looks good right up it. Instead of add L1 to EDX, I just put subtract 1. So right, so stupid, stupid.
Well, it's close. I would consider those minor, somewhat minor, issues. But it is kind of flipped. So you still get partial credit for the other parts. Yep. I think we should combine this class with English writing so I can grade you on the naming of the labels.
No. Well, you're pressed for time and you make stupid little mistakes because you can't get through
Yeah,
all of
I know.
them.
Yeah. And that's why the partial credit works out for people who get most of it right. Just minor points. Just okay, I got a mistake here. As long as it's not a conceptual mistake, that's not too bad. Conceptual mistake is going to cost because that's more important. Yep.
But you can still get credit if it's a conceptual mistake, right?
If it's a conceptual mistake, okay, remember the A, B, C, D, F thing?
Yeah.
No answer obviously is an F, right?
Right.
Completely wrong answers would be an F. But conceptual mistakes would be a D because I cannot let it pass.
But it's still points.
There will still be points, yes.
Yeah,
There will still be points depending on how bad it is.
Yeah. And how many concepts you're being tested on in the question. If you do one concept wrong, but you're tested on like 3 concepts.
That's what I was wondering about. If you get one concept wrong on some problems, you might get every other
cascade.
subsequent concept wrong as well. So it's kind of like a dominoes piling over kind of thing.
Well, I can tell you one thing. In the previous year, when I graded this one here,
Yeah, that one. If you get something
when I graded
wrong,
this
really
one,
wrong.
if you get one step wrong, I would definitely ding you for that one. But if the following steps are consistent with the earlier mistake, you will still get partial credit for that.
That's great. That's good.
I don't know whether the math professors do that or not in the proof, because if you do one step wrong in the proof, then you're in the wrong path already, and not that may not work out.
Yeah.
But in this case, if I can still see that you can understand the further instructions, and do it correctly, I can still give you partial
Like
credit.
from let's see, line 3 onwards, L1 plus 10. If I had something L1 plus something else, and that would mean everything
Then I'll be
else.
looking at whether they are consistent or not, because
Yeah, right.
the L1 plus 10 would only affect the next instruction, but it would not have any impact to this one. So you should still get BX correct, even though this part will be incorrect, right? Yeah. So I'll be looking for those things, So it's not going to cascade automatically if you get one little mistake early on.
Yeah.
Yep.
Except for jump L, jump B.
Now, of course, this does not apply when you are at work.
Well, yeah, not under the same constraints.
But the program mostly worked, The Mars probe, mostly landed.
Well, it landed.
It started to descend.
Right. It's on the planet. That's what you want, right?
All the pieces are on the planet.
right.
Yes, all the pieces are on the planet, just in pieces.
Yeah, right. We have added to the total mass of Mars by one
Do,
row.
do I still get my partial salary this month? That would be a kind of funny question to ask. Of course,
Your paycheck will come when the data starts coming.
your superior will probably ask you, so whom did you take your classes from in college?
Oh, yeah.
Who gave you this
Dr.
idea
Ted.
of partial credits? Alrighty, so you guys feeling kind of okay? I mean,
I feel better about the final now, I guess, somewhat.
how so?
I mean, I don't know.
Don't challenge him.
I did not say anything. I'll take that back.
Is the final cumulative, right?
The final is cumulative, but with more focus on the later stuff, which means we're going to deal with more of the parameter stuff, call frame, stuff that we have not even talked about yet. So it will have more focus on those things. But we cannot be like, some of this stuff will still be there because it is a part of the key concepts. It's really hard, to compartmentalize, programming classes.
Yeah, because this right here is like going forward from here. This is going to being able to count where you're at bitwise is going to make a big
Yep.
difference. We'll start
Yep.
counting on the stack and jumping out. Are we going to end up jumping out to do like CN, integrating CN assembly? At the
Well,
same
we'll
time?
see how far we can go because we only got 2 weeks left.
Yeah,
Yep.
that's a lot to do in 2 weeks.
There's a lot of stuff to do in 2 weeks, but if your foundation is solid, we will still be able to move forward pretty quickly. All right. Well, have a nice Thanksgiving. I hope you guys have. I'm not giving you homework assignment so that you
Thank
guys
you.
can enjoy your Thanksgiving.
To do the other assignments.
Yeah. Right. Oh, you guys got homework assignment from your other classes?
From other classes,
They
yeah.
wouldn't. They would not let you leave you alone.
That's all right. It just makes what you've given that much more special.
I thought about giving you guys homework assignment, then I thought, hey, this is right after the exam. You guys have have Thanksgiving, and I'll see you on Tuesday, next Tuesday anyway. So I can give you the homework on Tuesday.
Double up on homework on Wednesday is what you're saying.
Yep, double up. Alrighty,
A nice Thanksgiving.
you guys have a nice day too.
Two.